actually go about making confidence intervals, we want to be able to make sure that we can find our point estimates, p hat and q hat, meaning using our samples that they actually give us, can we come up with our proportions, the p hat for the sample and the q hat for the sample. So let's take a look at this first example. This first example says, suppose we want to estimate the number of Polk State College students who favor changing the name of Polk State College to Polk Community College. We select a random sample of 200 students, and 76 say that they are in favor of the name change. And what we want to do is find a point estimate, p hat, and q hat. Well, if we remember right, remember that p has to do with the probability of success, just like it did in binomial distributions, except for the hat just means we're looking at a sample. So don't worry about the little triangular type thing. That's just a little hat saying that we're looking at a sample. Well, success means that they are in favor of the name change here. Well, how many are in favor of the name change? 76 out of 200. So that's how we're going to make up our p hat, is by taking our 76 divided by our 200, and we would like our probabilities, our proportions to be here as decimals, so let's go ahead and turn it into a decimal rather than reduce this fraction. What we end up getting is 0.38. Then we can find our q hat, because p hat and q hat are complements and they have to add up to 1 by taking 1 minus what we got for p hat, which is 0.38. That will give us q hat, which is 0.62. So remember that p hat, though, is 0.38 is the people who are in favor of the name change, whereas the 0.62 are the students who are not in favor of a name change. In this next example, we have a survey of 1,000 adults in which 520 of those 1,000 believe that the role of unions in protecting workers' rights is as important today as it was in years past, and they're asking you to find point estimates for P and Q. When they use that term, point estimates, it means that they're just trying to have you find P hat and Q hat. That's all we're doing in these. Well, success is believing that the role of workers' rights is just as important today as it was in the past. So we'd start out with our 520 out of 1,000 as our proportion. So 520 out of 1,000, which gives us 0.52 for our P hat. And then if we wanted to find our Q hat, remember P hat and Q hat have to add up to 1, so I can do 1 minus 0.52, which gives us 0.48 for our Q hat. Now the question is, what are we going to do with all these P hats and Q hats? Well, we want to find our confidence interval using the P hat and the Q hat. And luckily we can have our calculator do quite a bit of this, but we can also do it by hand. It's really up to you. But we're going to make our confidence interval like we were talking before. We've already got part of what you need for the confidence interval, which is the P hat that goes in the middle. The part we don't have, our calculator can either find, or we can do this ourselves, which is finding that E, that margin of error. Because we're going to add the margin of error to get the higher end, and we're going to subtract the margin of error to get the number on the lower end. So let's talk about how we can use our calculator to do most of the heavy lifting for us. So in order to have a calculator calculate a confidence interval for a population proportion, P, what it's going to do is we're going to have to go into our stat key on our calculator, and then we'll arrow to the right 2 times over to tests, and we're going to arrow down a whole lot until we get towards the bottom where we get to what's called a 1 prop z int. And I know that looks wordy, but the 1 means that we've got one proportion, P, which is all we're going to be looking at here, at least to begin with. So we'll look at 1 proportion P. And the Z tells us that it's going to use Z values to do this. And the int stands for confidence interval. So when you see the int, it means that it's going to do a confidence interval for you. Okay, so if you press enter once you hit that one prop Z int, then what you need to do is give it a couple of pieces of information, not even much. So generally speaking, we find our p hat first. Whatever's on top of the fraction is going to be your x value. Whatever's on the bottom is your n. So when you find your p hat, whatever's on the top will be your x. That's what you're going to input first. Then whatever's on your bottom of your fraction is your n. And they do need to tell you, if you're going to actually make a confidence interval, what level of confidence you have. Notice that's your C level. Normally, they do give it to you as a percentage in the problem, so you need to convert it and put it in as a decimal. Then once you have all your information inputted, then you'll go down to the bottom and you'll select calculate. Notice for this set of information I just randomly made up and inserted, I get a confidence interval that looks like the following. I get a starting value of 0.0, depending on how you round, 36. That is what this first value is. Let's see, is the 0.036, and the ending value for our confidence interval is the 0.064, it looks like. 0.064. And so that'll be our ending value for our confidence interval. So if they just ask for the confidence interval on this one, you'd say, okay, well, it starts at 0.036 and ends at 0.064. And that would be just your confidence interval. Generally, that isn't all they ask for. They would ask for a couple of other things as well. They might ask for what your p hat is, which is in the middle. Well, our p hat, they actually give that to us too, is 0.05. If you weren't sure though, you could just divide the x over n, which is the 50 divided by 1,000, and you do get the 0.05. And you could find the p hat because it has to be in the middle of your two values you already have. It has to be in the middle of the 0.036 and 0.064. So for it to be in the middle, you'd have to add those up and divide by 2, average them, and you will get the 0.05 for your p hat. Now notice they don't actually tell you what they're actually doing behind the scenes, which is they're using a z value to do this, and they find what's called a margin of error. But you can find the margin of error, which is the value on either end that's either added or subtracted to get from the 0.05 to the 0.064 or the 0.05 to get to the 0.036. So we can figure out what the margin of error is if we want. So if we wanted to find out the margin of error for this one, you could do it one of two ways. You could take the 0.064, the high end, and subtract the middle piece, the 0.05, and what you'll get is 0.014. And you could do the same thing between the 0.05 and the 0.036. If they are slightly off, you know why it is? It's due to rounding, because we rounded here and we had to round here. So if they are slightly off, that's why. Or what you can take is the entire distance from one end to the other, which should be both errors added up, and then just divide that by 2. It's really up to you. Both ways will work. Okay, so let's continue on. So what does this mean? It means, what if they give me an example of a confidence interval? So suppose I have a confidence interval of 0.04 to 0.06. Can I work backwards and figure out how this confidence interval is set up? And absolutely you can. So you have your starting value of 0.04, your ending value of 0.06. Could you find everything they didn't actually explicitly tell you? Could you find the p-hat that normally goes in the middle? And yes, you can. Well, to find the middle value, the p-hat, you take the beginning and the ending value and you just average those. 0.04 and 0.06, add them up and divide by 2.